So now we're going to talk about target objective and advantageous solution. You already know how to identify variables, translate the constraints into a system of inequalities, graph the system of inequalities, find the polygon of constraint, and find the vertices of your polygon of constraint. So we're going to look at a problem that I illustrate all of those concepts. So here's the problem. I suggest that you take a few minutes to read it, try to do it on your own, and then start the video again to check the solutions and find the explanation if you're not sure that you got it right. So the first thing you have to do is define your variables. Now be careful, you have to be precise when you define your variables. So here, when you read the problem, you have to find what are the two things that will change in this problem. So they're talking about 20 passenger buses and 48 passenger buses. Now, when you define your variable, you can use X and Y, but make sure you don't just write 20 passenger buses because it could be the length of the bus, the size, the weight, anything. So really what you're talking about here is the number of 20 passenger bus. You could start with 40 also, it doesn't matter, but that's why you need to identify clearly your variable because somebody else could decide to go the other way around, and that's okay. There's no, in this case, there's none of them that is independent or dependent. So these are your two variables. Now you need to translate each constraint into an inequality, and that is going to form your system of inequalities. Now, because we're talking about number of buses, the first one you need to think of is the non-negativity constraint. X has to be greater or equal to 0, and also Y, because that means they're positive. So this is going to be my first equation and my second equation. The third one, it says that the company must transport at least 400 students. So how do you link the number of buses with the number of students? Well, if I have one bus of 20 passengers, I can carry 20 people. So I need to do 20 times the number of buses that carry 20 people plus 48 times the number of buses that carry 48 people. And that has to be at least 400. So at least means greater or equal to. Equation number 4, it's telling you that it needs to be at most 650 students. So at most is going to be the same thing, so 20x plus 48y, but at most means it has to be smaller than or equal to 650. And your last one, it talks about the money. So the cost for a 48 passenger bus is 9,000, and it's this much for 20, and there's a budget of 140,000. So how do you link the cost with the number of buses? Well, if you have one bus of 20 passenger, it's going to cost 8,100. So that's for one bus. So the times the number of bus you're going to have, plus 9,000, and that's for the other kind of bus. And your budget is 140,000, so you need to be lower than that. Could you be equal to? Yes. Okay. So now this is your system of inequalities. After that, what you need to do is you need to do the graph, because then you're gonna have to find the vertices, each of the vertices of your polygon. So now to graph the first one, x is greater or equal to 0. So this is here. X is greater or equal to 0. So this is my line number 1. The second one is here. Y is greater or equal to 0. This is my second one. Now to find the third one, it's not in the right form. So what I suggest you do is you isolate your y. If you isolate your y, you should get minus 20x over 48 plus 400 over 48. So what I did is I brought everything on the other side, divide by 48. So if I want to graph that, well, you can also find some point to help you. Or actually, I think that's the one they already graphed. Oh, and there's no numbers also here. So you should add some numbers. You can write 1, 2, 3, or just write some of the numbers. So it goes by 1, and here it's 20. Okay, so this is your line number 3. They already did that one. It's gonna go up, line number 3. Line number 4 is the same thing. So you need to isolate your y if you want to be able to graph. So it's gonna be minus 5x over 12 plus 8.3, repeating. No, hold on, give me a second. Never mind my 8.3 here, that should be 13.5. So here 8, 9, 10, 11, 12, 13, 13.5 should be here. And your line must be parallel to the other one because it's the same thing. So here I simplified my fraction, but if I simplified on the top, I would get the same thing. So you need to draw a line that's going to be parallel, but it's going to be shaded down. So this is line number 4, and we're going to shade down line number 4. And the last one is line number 5. For line number 5, you can also isolate your y if you want. You would get something like 100,400 minus this x over 9,000. So it's not super easy to see the graph of that. So I suggest you do a table of value with 3 points. So check what happened at 0, check what happened at 20, and maybe at 10 in the middle, to be able to have 3 points so you can make your graph after. Alright, so at 20 it doesn't work because we're going to get in the negative. So I checked at 10, it was 6.5, and at 17.2 here it was 0. So you can go 20, 19, 17.2 is around here, and at 0 here it was 15.5. So 15.5 is around here, and at 10 we have 6.5. Something like that. So yeah, then you draw your line connecting these points. So this is your line number 5, shaded down. So if you want to find your polygon, you need to follow all your arrows, and you can see that your polygon will be here inside. Here. So it's creating 1, 2, 3, 4 points. So there's 1 point here, 1 point here. I'm going to start this one. I'm going to call this one A, this one B, this one C, and this one D. So what you have to do after doing your polygon is you have to find now the different coordinates. So you can do that by using system of equations, or you can, if your graph is precise enough, sometimes you can see it on your graph. So you should get A is the intersection of 1 and 3, and your answer should be 0, 8.3 repeating. B is the intersection of 1 and 4, and you should get 0, 13.5. C is the intersection of 4 and 5, and the answer is 4.17 and 11.81. And D is the intersection of 5 and 3. So 3 and 5. And your answer should be 14.94 and 2.11. Something like that. Now for each vertex, you have to check if it's a solution pair in the situation, and you have to explain your answer. So what does it mean? So can it be that you have 0 buses of 20 people and 8.3 repeating buses? Of course not. You cannot have 8.3 buses. So all of those are decimal. So they are not, okay? So they are not a solution pair in this situation. So if I was asking you if there's a solution, you have to say no. Now, what would be the solution? You would have to check the points that are closer, and you're going to be able to check if those work. So if the first one is 0, 8.3, we would have to take the next one here. What would be the next one? It would be 9. So we would have to check at 0, 9. What is the solution? And or at 1, 8. Let's say here, 1, 8 would also be a solution. And so on for the other points. And you're going to see why we need to know that, because that's going to be important for the next thing we're going to do together. So this was the official answer. Now let's look at what we're going to do next with that. Okay, so what you're going to have to do is you're going to have again to define the variables, find the system of inequality, but we're going to have to find the rule of the optimizing function. So that's the new part, and that's the last part of this chapter. How do we optimize those problems? So you should take the time to read the problem, try to find the variables and the system of inequality, and then we're going to find the optimizing function. So the two variables you should get I'm going to use x as the number of, and then you can decide, but I'm going to use the number of large hangers and y as the number of small hangers. Then you have to find the system of inequality. So remember, because we're talking about number of hangers, x has to be greater or equal to 0, and also y has to be greater or equal to 0. And then they're telling you that they have at least 300 hangers. So if they have at least 300 hangers, you could write that x plus y has to be greater or equal to 300. And what I'll do is I'll just put this over here. They're also telling you that you have at most 1,000. So at most 1,000, you would write it like this. X plus y is at most 1,000. And the last one is where most of you struggle. She needs at least 3 times more large hanger than small hanger. So when you think about that, do you have more large hangers than small hangers? Yes, you have 3 times more. So that means that your large hanger, they have to be 3 times the small. Sorry, I forgot small here. The small hangers. And it has to be at least, so I'm gonna put it like this. And if you're not sure, give yourself an example. So if you have, for example, 10 small hangers, how many large hangers would you have? You would have 30 or more, right? So check if it works in your equation. If you plug in here 3 times 10, it's gonna give you 30 here. Okay, so you know you're right. You know you got it right. Now the last part is where we're going to be doing the optimizing function. They say that each large hanger costs 55 cents and each small hanger costs 35 cents. So if I want to find the cost, so I should actually put that in my variables, because I'm going to put it here, but C could be the cost in dollar. And I'm gonna have to minimize, because usually we want to minimize the cost. And my rule is going to be C equals, and you have 55 cents, so 55 cents for the large hanger plus 35 cents for the small hangers. So this is the rule to optimize. And then when we're going to be drawing our polygons and we're going to have our points, we're going to take each point and we're going to check, when we plug it in our rule, which one gives us the minimum cost. And that's going to be our optimized solution. So here what we did is we created the polygon of constraint. So we know you can do that. Now in each case, they want you to use the this optimization function. So this is the function we're going to use to optimize. And you have to list the order pair in order to find the minimum or the maximum. So if, let's say, my points are A, B, and C, so I'm going to write A is 2, 3, B is 12, 16, and C is 14, 1. And then I'm going to plug that in my rule to see who has, in question 1, they want you to find the minimum, and in question 2, they want you to find the maximum. Now, if you're showing me the work for the first one, so 3 times 2 is 6 minus 2 times 3, so that's 0. You don't have to show me the work for each of them. But of course, if you do, I believe you have less chance of making mistakes, right? So you find your values for each of them, and then you'll be able to find after who has the maximum and the minimum. So you should find 4 here and 40 here. So which one? The question is, use the method to determine the minimum. So here the minimum is 0 and the maximum is 40. Be careful, sometimes they're going to ask you which point gives you the minimum. So then you would have to answer the point 2, 3. And which point gives you the maximum? Then you have to give the points 14, 1. So be careful, read the question carefully. So we're going to do one more example to show you more steps. So in this case, they give you the system of inequality. They want you to represent the polygon of constraint. So first you have to show your polygon. So if I'm doing the polygon, my first equation would be x is greater or equal to 1. So that's going to give me this. That's line number 1. Line or inequality number 2. 1, 2, 3, and then it's greater than. Whoops, sorry, I did 4. Hold on. That's my line number 2, and it's greater than or equal to. For my line number 3, I know I have to start at 2, and my rate of change is 1. So 1 up, 1 across, 1 up, 1 across. So it's going to give me this line. That is line 3, and it's shaded above because it's greater than. And then line number 4, I start at 20 and I'm going negative 2 over 1. So I'm going down 2, forward 1. So your line number 4 will look like this, and it's smaller than. So it's going to go like this. So then you can draw your polygon. Your polygon going to be inside here. And then in number 2, they ask you to calculate the coordinate of the vertices. So I'm going to just take another color so we can see better. So we have 1 here, and 1 here. So you can call them A, B, C. And then you're going to show your work. So A is the intersection of line number 1, which is x is equal to 1. And line number, line number 1, and we can use line number 2, I guess. Line number 2 is y is equal to 3. So easy to find that our A is 1, 3. You do the same for B and C. So I highlighted in yellow the answer, but I left my work, so if you need help, you can look at the work. The third question is identify the point whose coordinates allow you to attain the target objective. So the target objective, they gave it to you here. They wrote f of xy, or sometimes they'll call it z or whatever they're doing. They want you to minimize this function. So what you have to do to solve this problem is you're going to create a table here. So I'm going to show you how you can show your work clearly. So you can create a table of value with, oops. So in your table, you're going to place the coordinates. So I have A, B, and C. And I'm going to find what is the value of my optimizing function. Sorry, you replace with your x and y value. So it's going to look like this. 1 plus 3 is equal to 4. And because you showed your work for the first one, you don't have to show your work for the second one. You just have to add them up. So if you want, they're asking you here to find the minimum, then which point would be your answer here? It would be point C. So if you have to write down your answer, you would write point C is the one. Not point C, point A, because you're looking for the minimum. Okay, so the minimum is this, but which point is point A13. So what I did for you is I listed all the steps that you're going to need when we're going to do optimization problems. So I suggest you look at all of those steps, make sure you understand them, and that's what you're doing, and write them down in your Word on your memory aid, because you're going to be able to use that if you need extra help, if you're not sure about your steps. Have fun doing optimization problems now.